Hey guys, how's it going? Mr. Dorado here with a brand new video on Chapter 6. This time we will be looking at exponential equations, and in particular we're going to be looking at what's called exponential growth. Alright, so why don't we go ahead and get started? So that'll be our objective for today in order to be able to graph exponential functions. Alright, so in order to do that, we want to actually get a basis of what we understand in terms of functions. So why don't we take a quick look at our linear functions, so stuff that we've looked at before in the past, but now we're going to go ahead and see how that relates to our new topic. So first things first, let me go ahead and get my pen here. Alright, so in this linear function we have a few ordered pairs here, so let's go ahead and graph it. So we have negative 2 comma 0, so right here, negative 1 comma 2, which is right there, 0 comma 4, 1 comma 6, and 2 comma 8. Alright, so that's what we have. Now we can go ahead and graph a straight line going through those points. And that was the best I could do there. So we now go ahead and talk about our domain and our range. Well, domain and range is actually pretty simple, not too crazy. So let's go ahead and do this before we start talking about domain and range. So remember guys, this graph here will go down forever and to the left forever. And on this side, it actually goes up forever and to the right forever. Okay, so when we talk about domain, well, we're just talking about the left and right hand behavior. So our x values, okay? Well, our domain is actually going to be x such that x is all real numbers. Okay, why is that true? Well, if it goes all the way left and it goes all the way right, then that means that it's going to include all real numbers, okay? So similar here actually with our range. Let's take a look at our y's. So our y's go all the way up and all the way down, and they go up and down forever. So then we also have y such that y is an element of the reals. So we would just say y such that all real numbers. And actually, why don't I go ahead and fix that? I don't like this terminology. I'm going to actually go ahead and use this here. Once you guys get to a little bit of a higher level math, you guys will use something like that. So this is x such that x is an element of the real numbers, and y such that y is an element of the real numbers. Okay, it's just kind of like an E symbol there, and then your R to demonstrate all real numbers. Okay, all right, let's go ahead and talk about now our exponential functions. So in exponential functions, let's go ahead and graph a few points that we are given. We have negative 1, 1/2, 0 comma 1, 1 comma 2, 2 comma 4, and 3 comma 8. So if you guys can see already, kind of starts to taper off there. So this here is our exponential graph. Similar to what we did earlier, let's go ahead and identify our behaviors. So this thing is going to keep going to the left, but it doesn't necessarily go down. It actually stops at that line right here, which is actually the line y equals 0. That's the highest, that's the lowest it will go. It will keep going to the left, but it won't go down. It'll stop at y equals 0. Now let's take a look at the other side. So this other side will go to the right forever, and actually it does go up forever as well. So again, remember, domain, we're talking about our x values. So what are our x values here? Well, if it goes all the way left and all the way to the right, then we have x such that x is an element, is an element of the real numbers. All right. So x such that x is an element of the real numbers. All right. Now on the other side, we're going to talk about the range. Well, let's see. Let's go ahead and talk about the range real quick. On the range, we're talking about all the upwards and downward behaviors of this graph. So again, we go from smallest to greatest. So from the bottom, what's the lowest value that this reaches? It's actually 0, okay? But it keeps growing, it keeps going up. So actually, our range here is y such that y is greater than 0. So let's talk about that real quick. Again, that graph is going to keep going up. So all positive values will work. However, the lowest that this graph actually goes is towards the line y equals 0. But it never actually touches that line, okay? Because it doesn't touch that line, it's just a y is greater than 0, okay? So keep that in mind as we are looking at the rest of these functions here. All right, so let's go ahead and start looking a little bit at our tables here. So first things first, let's take a look at what's happening in this first table. So it says determine which table of values is a linear function and which is a exponential function. And actually, why don't we take a quick look at table 2 first. Now I want you guys to notice something about the y values here. Okay, so on our x values, we obviously know that we're increasing by 1, okay? We're increasing by 1 because we want to write down all those values. However, as we're going from this one to this one, on my y's, what did I do? I subtracted 3. From 0 to negative 3, again, I subtracted 3, subtracted 3, subtracted 3. Okay? So to get from one to the other in my y values, I'm subtracting 3 each time on table 2. Now let's take a quick look at table 1. So, similarly, let's go ahead and see what's happening. To get from here, to get from here to here, what did I do? Well, maybe that one's not so clear yet. How about from here to here? 1 and 3. Well, you could say, oh, I added 2, but then from 3 to 9, you're not really adding 2 anymore, so it's not adding. You're not adding here. However, you are multiplying by 3. And see if that makes sense, guys. 1/3 times 3 is 1. 1 times 3 is 3. 3 times 3 is 9. And 9 times 3 is 27. So what do you notice? In one of those tables, we went ahead and multiplied by 3. And in one of them, we are just subtracting by 3. So which one's which? Can you guys tell which one's linear and which one is exponential? All right, well, hopefully you guys are able to tell that table number 1 is actually an exponential function, and table 2 is a linear function. Okay, because remember, guys, linear functions will always add or subtract the same number to the y value. Okay, so notice on table number 2, we actually subtracted by 3 each time. That means it's a linear function. So this blue one here, this table 2, was my linear function. Now my table 1 will actually be our exponential function. And what happens there? Well, we multiply or divide by the same number each time. By the same number to every y. Okay? So linears, we're adding and subtracting the same number. Exponential, we are multiplying or dividing the same number. So let's see how that's applicable here in our first practice problem. So let's first discuss what we should be adding here, or rather, not what we should be adding, but what we should be writing for our x values. Okay. Well, usually when you're talking about exponential functions, and as you can see in our graph here on the side, the lowest we want to go is actually -2. And the reason why is because you should always try to get a 0 here in the x value that goes in the middle. So that means you want to go 2 lower values and 2 higher values. So again, just like earlier, go up by 1 or go down by 1. All right. So let's see what we actually get when we start substituting this -2 into that x, or this -1 into that x. And we're going to do that for every single one of those x values. All right. So let's see. I'm going to actually start off with the easy one. Okay. I'm going to go ahead and start off with 0. Okay. So y equals 3 to the x, but our x is now 0. Well, what is that? 3 to the 0? What's anything to the 0? That's 1. Okay, so that is 1. Now let's do the same thing with 1. So this is y equals 3 to the x, but now our x is 1. So what do we get? What's 3 to the 1? 3 to the 1 is 3. Let's keep going. All right, so let's keep going. So this is y equals 3 to the second, but 3 to the second is just like 3 times 3, which is actually 9. All right, so now let's do the harder ones. Now we're going to look at those negative exponents here. So this is y equals 3 to the -1. But remember, guys, what happens with that? Okay, we don't like negative exponents. So if it's in the top, we have to send it to the bottom and then turn it positive. So this is really 1 over 3 to the 1, which is just 1 over 3. Okay, similarly here. This is y equals 3 to the -2. We don't like that. We want positive exponents, so we're going to send it to the bottom. So this is going to be 1 over 3 squared is 9. So these here are my new y values. Okay, those are my new y values. I had my original x values. So let's go ahead and actually graph this now. So let's see. So we have our first order pair is -2, comma 1/9. So -2 1/9 should be somewhere around here. Okay, -1 and 1/3 is somewhere around right there. 0, comma 1 is right here. 1, comma 3 is right there. And finally 2, comma 9, excuse me, 1, 2, 3, 4, 5, 6, 7, 8, 9 is right there. So we're going to go ahead and join those with a straight, or not a straight line, more like a increasing line, but obviously mine wasn't that great, so let's try that again. That was a little better, not that great, but anyways, you guys get the idea. So again, it kind of tapers off, and it actually doesn't go below the line y equals 0. So let's now start talking about our domain range. So once again, if it helps, guys, draw the behavior of the endpoints, or the end behavior, I should say. Okay, and I always like to do that by drawing those arrows. Okay, so we're identifying the end behavior here. So it looks like here on the left side. Okay, so I'm focusing right now on this side here. Okay, on that side, it looks like it's going to keep going to the left forever. Okay, but not necessarily down forever, because it actually tapers off at y equals 0. Okay, now let's take a quick look at this side. So my line looks like it's going to go up to the left. I'm sorry, up and to the right forever. So that means I'm going to go to positive infinity on my y's and to positive infinity on my x's. So let's talk about domain. Once again, domain is x, range is y. So our domain, if we go all the way left and all the way right, then we have no limit at all. So we go ahead and write x such that x is an element of the real numbers. All that means is every single x value exists in this graph. Okay, now let's take a look at our range. So now our range here, we have to look at our up and down arrows. Well, there's an up arrow here for sure, but there is no down arrow. And the reason there's no down arrow is because it doesn't continue going down. Okay, it actually tapers off at the line y equals 0. So I'm going to go ahead and write, oops, I need my pen tool here. So this is y such that y, okay, again, there's no limit to how high there you can go, but there is a limit to how low, and the limit is 0. It tapers off at y equals 0, but does my graph exist above 0 or below 0? Well, it's above, so its y is greater than 0. Okay? If that doesn't quite make sense, guys, I know range can be a little bit difficult with exponential functions, so make sure you are asking that question. Figure out why it is that it is y equals, I'm sorry, y is greater than 0. I'm even confusing myself here. Okay? But just remember, usually domain left and right for an exponential function will be all real numbers. It's just the range that sometimes varies. Okay? It all matters on where it tapers off on your graph. Okay? All right. Why don't you guys go ahead and try out number 2 on your own? So go ahead and pause the video and try that one out. We'll come back and talk about it. All right, guys. So let's take a quick look at number 2. So first things first, remember, go ahead and write your values for x right away. Remember, always try to have the 0 in the center, and then just go up and down by 1. So -1 and -2, and then go up by 1, so 1 and 2. All right, now let's do the same thing over here. Actually, before we even do that, why don't we actually go ahead and start substituting those values in for x. So if I do y equals 2 to the 0, that is just going to be 1. Okay, so my first order pair here, and I'm just going to write it on the side if it helps, is going to be 0, 1. If I do y equals 2 to the 1, well, that's just 2. So my second order pair is 1, 2. My next order pair is 2, 4. Now I can go ahead and take a look at the negatives. Again, guys, the reason why I start off with the positives is because it's kind of easy to see, all right, what these values are actually going to be. So let's go ahead and keep going. This is y equals 2 to the -1. Again, we don't like negative exponents, so I'm going to send it to the bottom. So this is just 1/2. Okay, so my next ordered pair is -1, 1/2. And finally, this is 2 to the -2, which is 1 over 2 to the second, which is 1/4. So my last ordered pair is -2, and you don't have to write the ordered pairs on the side, guys. Just you should be able to read them just from the values you have already found. Okay, but if it does help, go ahead and draw those on the side there. So let's go ahead and graph these. So -2, 1/4 is right around here. -1, 1/2 is right around there. 0, 1 is right here. 1, 2, and finally 2, 4. Right, so if you have that, you are in good shape. Let's go ahead and graph this. So we have a line that looks like that. And notice once again, guys, it is tapering off on the end there. It does not cross the line y equals 0. So let's go ahead and now identify our left hand and right hand behaviors. This is going to go up and to the right forever, and then over here on the left side, it's just going to go left forever, but it doesn't go down because it stops at the line y equals 0. Okay, so let's talk domain and range. Domain. no limit to how far left, no limit to how far right. So my domain here is x such that x is an element of the real numbers. So again, all real numbers is my domain. And then my range, well, let's see. My range here, it does go up forever, but it doesn't go down forever. It tapers off at y equals 0. So again, let's go ahead and write that down. It's going to be y such that y, and we said it tapers off at y equals 0, so I'm going to put a 0 there. But again, where does my graph exist? Is it above 0 or below the line y equals 0? Well, it's above, and above is always greater than. So y such that y is greater than 0. All that means is all the y values on this graph are greater than 0, meaning they're all positive. It never goes negative. Okay, and usually that's what you'll find. If you, as long as you have a base that is positive, you'll notice that you will never get y values that are negative, regardless of what exponent you're raising it to. But anyways, that's for a different time and for a different chapter. So hopefully you guys got number 2. I think I'm only going to do one more of these, actually maybe 2 more with you guys, and then we can go off and do a few others on our own. So let's go ahead and try out number 4. I'm actually going to skip number 3, but it's very similar. Let's go ahead and try out number 4. I want to do this one because it has a different base, not 2. All right, so same thing. Always, right from the get-go, guys, put in 0 in for your x. Okay? And then, again, always go up or down by 1. So -1 here and then a 1 there. Now I have all 3 of my x values. Now it's just up to me to figure out what my y values are. So again, all we're doing here is substituting this in for x, then this in for x, and this in for x. Okay, that's all we're doing. So let me go ahead and erase those because that looks ugly. So let's try this out. All right, so this is y equals 2, 3 raised to the -1. Y equals 2 times 3 raised to the 0. And y equals 2 times 3 raised to the first. Again, I always like to start off with 0. So this is y equals 2 times 3 to the 0 is just 1. So this is 2 times 1, which is just 2. And again, if it helps you guys, write the ordered pair there on the side. So this would be 0, 2. All right, let's continue. Now I'm going to do the positive one. So this is 2 times 3 to the first is 3. And then 2 times 3 is just 6. So my next order pair is 1, 6. And then finally, this is 2 times 3 to the -1. Well, this is really 2 times 1 over 3, which is actually just 2/3. So my next order pair here is -1, 2/3. All right, let's start taking a look at what this actually looks like on our graph. So I have -1, 2/3, so that's right around here. 0, 2, and 1, 6. So actually, if you guys can tell, this is actually increasing or has a higher exponential growth. So once again, draw my graph. Always tapers off. It always seems to be tapering off, and you'll start to notice that, guys. It will always taper off at y equals 0, depending on the value we have for a in terms of our base and the value we have for b. Okay, so let's go ahead and see what we have for our domain. So again, domain for all exponential functions, what is it? X such that x is an element of reals. Again, if you're not convinced, remember, there's no limit to how far left you're going to go, and there's no limit to how far right you're going to go. So there is no limit to how many numbers you're going to choose, so we have to do all real numbers. Okay. Now for my y values, once again, we're going to do y such that y, well, let's see, what values do we have to choose? Is there a limit to how high you can go? No. Is there a limit to how low you can go? Yes, the limit is 0. And then you have to ask yourself, that graph exists above 0 or below 0? Well, it's above, so it's y is greater than 0. Right? Okay, guys, so one last one, and you guys should be good to go. So we're going to go ahead and do number 5. So why don't you guys go ahead and pause the video right now and try out number 5. See how you do. All right, guys, let's take a quick look at number 5. Let's see if we are understanding finally what it means to have an exponential function and how we can show exponential growth. Excuse me. So again, start off in the center with your 0. It will always help you graph your function if you start off with 0. Again, I like to I like to choose one value that is smaller and one that is larger. Again, all we're doing is substituting those x's into our original exponential function to find our y's. So let's go ahead and do that. So this is y equals 3 times 2 to the negative 1. Y equals 3 times 2 to the 0. And y equals 3 times 2 to the 1. And again, I always like to start off with the 0, then the positive values. So let's go ahead and start off here. This is going to be, this is going to be 3 times, well, 2 to the 0 is just 1. So 3 times 1 is 3. So my actual order pair is 0, comma 3. So I'm going to go ahead and start graphing that right away. 0, comma 3. Let's look at this positive exponent here. So this is 3 times 2 to the 1. 2 to the 1 is just 2. So this is 3 times 2, or 6. So my ordered pair here is 1, comma 6. And finally, last one, here we have, 3 times 2 to the negative 1. Well, 2 to the negative 1 is 1 over 2, or 1 half. Okay? And that is just going to be 3 halves. So my final order pair here is negative 1, comma 3 halves. So once again, let's keep going. Let's go ahead and graph both of those. So negative 1, 3 halves is right there. 1 comma 6 is right here. And although it doesn't look like it's tapering off all that much, guys, you will eventually start to taper off. So here, your graph is going to look something like that. And if that would continue, it would go all the way left, never crossing the line y equals 0. Okay. Later on, when we get further into this chapter and into new chapters, you guys will start to understand why that's true. But again, for now, let's go ahead and talk about our domain, which is our x values. So no limit to how far left, no limit to how far right. So my domain here, as is for all of our exponential functions so far, it's all real numbers. Okay. Now our range, which is our y, and again, guys, you can start off right away writing that. If you can start off with that, you're halfway there. Now we just have to figure out if there's any limit to how far up or how far down this thing goes. There is no limit to how far up this will go, but there is a limit to how far down it will go. It means actually we are gonna taper off just like we have in the other ones at 0. So I'm gonna go ahead and put a 0 there. And again, does my function exist in the top? So above y equals 0 or below y equals 0? I'm hoping you're saying above, so that means greater than. So domain and range are just like what they were for every single one of these exponential functions, actually. So those didn't change very much. But again, we'll get to why or how they changed later on. But for now, start looking at this, guys. Start making a few conclusions as to why. Look at those values. What do you notice about them? Yeah, well, there's a lot of 2s, a lot of 3s, but even more so than that, guys. There's something embedded in all those numbers that makes each one of these problems have a positive exponential growth, okay? and it causes each one of these problems to have a very similar domain and range. Okay, but for now, guys, I think that is it for this section. So what I want you guys to do is go ahead and stop the video. I would recommend you guys try out a few more, see how you do on those. I know I didn't go through every single one of them, so go ahead and finish the rest of these notes, and make sure you guys ask if you do have any questions still. All right, guys, so I will talk to you guys soon, and yeah, we'll come back with part 2 of this section. All right, guys, see ya.